All right, everyone. I believe we are live on YouTube now. And just come back and check in on the chat. Shubham, the live sessions have typically been 1 hour on average, but we sometimes go on for longer depending on if there are questions, and sometimes we wrap up quicker if there isn't that much to talk about. So it's flexible. It's not a fixed time thing. Dharam, yes, I'm trying to get to a situation where I can turn on my camera. Not logged in from the right device for that. I'll fix that in a moment. Can you give me a +1 if this is your first time in a live session for this course? Okay, all right. That's incredible. That's okay. Thanks so much for joining in. So just for your information, we have been running these live sessions on a more or less weekly basis in the past. As I think someone was saying earlier, we post them to YouTube soon after. So even if you miss interacting live, you could watch the recordings later on YouTube. So it's not like you've missed out on much, but if you are here live, then the advantage is that if you have a specific question or you have a specific thing that you want to discuss, then you can actually make sure that that actually gets discussed. So I think there's definitely an advantage of your spending the time to be here. And I think in the meantime, yeah, I think somebody had asked earlier, what kind of questions can we discuss in this session? So as I said, so far we've normally been following a format where we typically discuss programming assignment problems from the past, because for the multiple choice questions, we typically share solutions and explanations in a PDF file. But for the programming assignments, either for some of them, the solutions are yet to be posted, or in other cases, even if the solutions are posted, they may not be as easy to follow because you have to still read and understand the code. So we have been following a format where Arjun usually ends up explaining what's going on in the programming assignments. So that's what we normally do. And we try to address anything else, any material that was not clear from the lectures, any questions that people have. That's what we normally do. Okay. So thanks to those who have posted the YouTube link for me. So right. So Faraz, yeah, thanks. That might well be the reason. It never occurred to us to experiment with a different timing. This time, I think it was more logistical, so we couldn't make it for some reason on Saturday. And this was something that we did impulsively, and it's really interesting to see so many of you here. So once again, thanks a lot to everyone who has joined. And I'm sorry, I'm not being very quick on the waiting room. I think, we have more people joining in, and, welcome to everyone who is joining. So I'm going to let Surya Prakash take over from me, who has joined us on Arjun's behalf, I believe also from CodeChef. And he's going to tell us about some of the programming assignments that have just gotten over from broadly speaking drafts. I think we have had assignments based on spanning trees and shortest paths and so on. I don't know precisely which ones you have up your sleeve, but I'll let you take it away and discuss these problems briefly for a while. And then maybe we will get down to, I'll keep answering questions in the chat. So folks, please keep it coming if you have any other questions not related to the assignments. But for now, I think Surya Prakash, if you could take it from here, that would be very helpful. Thanks.
Yeah. Hello, everyone. I'm Surya Prakash. I'm currently an intern at CodeChef. So, okay, we are currently on programming assignment of week 5. Okay, can I share my screen so that they can see the problem? Okay, I am not able to share my screen. Hello?
Yes, sir, we can hear you.
Just give me a minute. Uh, Ma'am, can you hear me? Hello.
Okay, sorry, that was something up at my end. I think I can hear you fine now. Sorry,
Yeah.
is the screen share not allowed for you yet? Let me just double
Yeah.
check. Yeah, sorry, just give me a moment here. Could you try now?
Yeah, I can share it.
Okay, awesome. Thanks.
Yeah. Oh, okay. So this is my first time taking a session, so bear with me if I will try to do my best. Yeah. Can you see my screen? Can you see the problem
Yeah,
statement?
you can. I
Okay.
mean, I can definitely see it. Thanks. Yeah.
Okay. So the problem is you are given a routed tree containing n nodes, which are numbered from 1 to n, and each node has a weight attached to it, which is given by wi. So the goal is to find pair of nodes uv such that u is an ancestor of v, and wu minus wv is maximized, and we need to output that maximum possible difference. This is the input structure. And so the constraints are like n is less than or equal to 10 power 5. So we can use DFS to solve this problem. So let me open this. Okay. So okay, we have a tree, some rooted tree. Okay, let's consider this for example. And each node has some weight. Let's say this is 1, and so it has W1, W2, W3, W4, W5, and W6. Now we want to find a pair of nodes UV such that WU minus WV is maximized and U is an ancestor of V. So for example, consider this. This is this and this pair. 2 is an ancestor of 6. So the value here would be W2 minus W6. And similarly, 2 and 3 is an 2 is an ancestor of 3 and 2 is an ancestor of 5. And 2 is an ancestor of 1 is an ancestor of 2, and like that. So among all such pairs, we have to find the maximum value, maximum possible value of WU minus WV. Okay. Just a minute. Yeah. Suppose we okay. So let's say
Sorry, I think I had to mute everybody. Don't know if you got unmuted because of that as well. Yeah, but I think we can hear you now again.
yeah. Okay. So we have to find the maximum possible difference WU minus WV, right? And U is an ancestor of V. So let's say we fix the node U and iterate over all the descendants of U. V is a descendant of U. Okay. So like we fix this node. Let's say this is U, and these are all the possible. This one, and this are all possible V that can be descendants of that are descendants of U, right? So what can be the we can just iterate over them and find the maximum value, maximum W value of those nodes, right? And then let's say that is equal to X. So X will be maximum of W value of this, W value of this, W value of this, W value of this, and this. And let's say that's equal to X. Then the maximum possible value with U as an ancestor will be WU minus WU minus X, right? So once we know this value for a particular node U, and if we compute that value for every node in the tree, this WU minus X, then we can just take the maximum among all those values, right? And okay, is this clear till now? Is anyone having any issue with this?
Sir, I have a doubt if you mind me asking.
Yeah.
Sir, half of the students here, I think, are from like the first semester of BCA, so they have no idea what's going on right now.
Okay.
Yeah, so
Yeah, let me just, if I can try to understand what's going on here. All right. So just to clarify, for everyone who is joining us, especially for the first time, and I think some of you are probably not quite sure why you're here, from the from the messages in the chat. So yeah. So okay. So just to clarify, this is I think the 10th live session that we are doing in a series of live sessions for a course called Getting Started with Competitive Programming. And yes, it is for beginners, but it is the 7th or 8th week of the course. So this is really a session intended for people who have been following along with this course for the past several weeks. Ananya, you can find the earlier sessions on YouTube. Bhavya, you got the link only today, but have you not been getting the links for all the previous sessions? So I just want to confirm, are you all enrolled in this NPTEL course, and have you been, submitting assignments for the last 7 weeks?
No, ma'am, we got this link from our university.
ma'am, we just got this link today and it was said that you should join this session. So yeah.
I see.
Ma'am, maybe register now in NPTEL, ma'am. That means if actually this is continuing, can we start from today itself or tomorrow itself? The new course, any available, ma'am? Any new course are available?
Okay, so this course will be available again from January. Yeah. And and yeah, this course is a little more than half over at this point, right? So I think you need to have submitted at least a certain number of assignments to be eligible for a certificate. And I think the enrollment for this course closed in sometime in August, I believe. So it really does seem to be the case that there's either some confusion. I also genuinely hope that you're not supposed to be in some other place. If somehow two Zoom links got mixed up, basically, then it's possible that maybe somebody wanted to share a meeting that was different from the one you're currently attending. So you might want to check with whoever sent you this link, because really this is a meeting that we, in fact, normally we never hit the 100 participant limit, to be honest. We have been running these sessions for a while, so that's why I was also a bit surprised. This is not to say, I mean, definitely a warm welcome to everybody who is here, but I just want to make sure that you're here for the right reasons. Yeah. So Aarti, yes, these sessions are connected with the NPTEL course on Getting Started with Competitive Programming. We are currently.
Can we watch that still without enrolling?
Yes, if you're interested, you can definitely watch. All the material is up there on YouTube and other places. Those of you who know what is going on, who have been doing this course for a while and who are not completely lost, could you please raise your hand in Zoom so I can just.
Actually, as you said that the course has started yet, ma'am. But if we want to continue in this course, how can we submit the previous assignments? Is there a chance of submitting them?
Okay, so I'm afraid it may not be possible to actually submit the assignments because you need to have an NPTEL login for that. But if you want to just follow along with the material, then I've just posted a link in the chat, and you can kind of find it. You can find all the material from there. Okay, so the materials for up to week 7 are available. And I think those who are actually participating in the course have been anxious about the release of week 8 and week 9 material. So that is definitely happening by tomorrow morning. For January course, Ananya, you can enroll from the NPTEL website. Okay. If somebody could please forward.
And ma'am, how can we join this course in the January?
Yeah, you can. Okay, so you can go to Swayam's website. I'm dropping the link for that. This is where they have a catalog of all courses. In fact, I think Ayush has shared a better link. Thank you. Swayam typically catalogs all the active courses and they have notifications for when enrollment. So typically watch out for enrollments in late November, early
Ma'am,
December.
are there any upcoming courses still, or we have to again start from January itself, ma'am?
As far as I know, the NPTEL schedule is such that these courses are wrapping up in October with exams happening towards the end of October and the new courses
Okay.
will start. I'm saying January, but I think typically they start actually towards the end of December. And Udit, sorry about the accent. I hope as long as you can follow what I'm actually saying, hopefully that's okay. Which programming language we're using? We're not married to a specific programming language. Typically in the lectures, we usually do C++ prominently and a little bit of Python here and there. You can, if you want access to the materials in terms of the code, I could share a link to our repository with you. Again, I think many of you in the call are faster than I am. So if you have the link ahead of me.
Excuse me, ma'am. In our university group, it was given the link was given that it is the introduction for the competitive programming. But where can we get the introduction to competitive programming, ma'am? Actually, if we want to join from January, also we must have something idea, na? That's why where can we get this introduction to the competitive programming such as
I think there's a
NPTEL?
link in the chat where you can access about it.
Yes, this link has been posted a couple of times, so you can.
Ma'am,
Yeah.
ma'am, if we want to continue this courses without enrolling just for learning, so where
Yes.
can we get the link for the upcoming sessions?
So Kushagra, there are two links in the chat. One which is a link to NPTEL, so I'll repost it. I think Ayush has just shared it.
Ma'am, most of us are beginners, na ma'am. That's why we want an idea what's this programming and everything. How many years, how many days this course will elongate and everything. Once we have to know, ma'am.
Okay, so right now, technically, as of today, Monday, we have started the 10th week of the course. So officially, the course will last for another 3 weeks starting from today. Okay, and you can find, yes, Neha and others, all of you who are referring to yourself as beginners. Yeah, so please don't worry about it. It's, I mean, of course, you're going to start somewhere. As I said, please don't worry about not being able to make sense of how this session started because the session was probably not meant for you. And I just say that in a completely logistical sense. I think there's probably been some mix up. I really appreciate it if you could, one of you who got this announcement could forward it to me at this address so that I can figure out the source of the confusion. But it seems like probably the two links just got mixed up. Yeah.
Yeah, ma'am. I do think the links got mixed up because like right now we are just learning the basic of C. So I don't think like this is for us.
This is probably just, I'm just a bit worried about the person or people who might actually be expecting you.
Yeah.
I'm not sure. So we had an unexpected footfall for sure. But yeah.
I just wanted to ask that what we are studying is right now is just binary tree something. I've heard about it, so.
Yeah, no worry. I mean, no worries. It's just, I mean, like if it's your very first time interacting with us with this course, then clearly it's going to be weird, right? So, I mean, okay, if you're really curious, we have been covering topics on graphs for the last few weeks, and prior to that, we have been doing some other standard things like greedy algorithms and so forth. I don't want to get into too many specifics here because it'll not be fair to the participants who have been following along in the course and they will just needlessly get bored. This is, I think that's correct. We're discussing material from up to week 7. Aisha, this is a course for beginners, but it's right in the middle of its execution. So not for beginners so much as for people who have been doing this course for a while. So I hope you'll come back. I hope you'll come back when the time is right. And some of you expressed interest in following along even without enrolling formally. That's really cool. There is a link to the course website in the chat, and I hope to see many of you back in January when you can actually enroll officially. I have no idea about the source of this confusion, so I'm really sorry for those of you
No worries, ma'am. Ma'am, I think it's just a mix-up.
Ma'am, is this going to be in our syllabus or is just an extra part?
I wish I knew. I am speaking here as the instructor of the NPTEL course. Unfortunately, I have really no context on your university and where all of you are coming from. And I'm once again so sorry for the confusion. We are about a little over 7:30 right now. I think I should have realized a little bit sooner that there was some confusion. But I think there may still be time to salvage the session that you were actually supposed to be in. Okay, so if you could please get in touch with whoever sent you this announcement and ask them if they're absolutely sure about the link that they sent you. Yeah.
Okay,
Ma'am, but the last doubt, ma'am.
Yeah.
How-
Sure.
How much long the course exists, ma'am?
It's 16 weeks, I think.
Okay. So
Means the total all courses, sir.
Well,
All
this-
courses.
okay, so I don't know about the broader context of other courses that you're doing. This particular course is 12 weeks, yeah, and from beginning to end. It's a little bit more if you account for like the stretched deadlines in the exam dates.
That means, ma'am,
Uh,
according to computer science, all courses will take how much time? That like I'm asking.
Okay, that will really depend on what combination of courses you take because there isn't really a fixed path for everybody, right? So, the answer to that is it depends. I'm
If
sorry.
we take each and every course, then how long it will take to complete all the courses in the NPTEL? That's
A
my
lot
doubt.
of time that is.
That I'm afraid may take forever because NPTEL has courses in every subject and at all levels. Yeah, what most people do is they chalk out a path for themselves by taking a subset of courses with a common theme. So that's what normally happens. So yeah, so the answer is right. It may be a lifetime's worth of an exercise. This just like if you write a script to count the total number of YouTube hours on the NPTEL channel, it will probably be a lifetime. I'm pretty sure. Anyway, so Aarti, there is a separate channel of NPTEL where we do record the live sessions. Again, the link to it should be somewhere on the website. So okay. I see. So it looks like, it looks like NPTEL has been experimenting with WhatsApp notifications, and maybe there was some mix-up. Once again, I'm sorry for anybody who may be left a bit flustered or confused right now. This was not our intention. And please don't be disappointed if you didn't understand. Like, I mean, just imagine walking into a random class in a physical classroom setting in a university. It's not likely that you will follow what's happening, right? So, so please do join us back when you're ready for it. Yeah.
Yeah, ma'am. Ma'am, and I did send you the link, the email we got since you asked for it.
Yes, I did.
Okay.
So thank you so much. I
No
really
worries, ma'am.
appreciate it. And I hope that we see you all back in a setting where we are not also
Yeah, ma'am, sure.
And good luck with whatever it is that you're pursuing right now. Please keep at your C course. I'm sure whatever you're learning is going to be super helpful. And you are all very welcome here, of course, but we don't want to bore you or leave you more, more confused. So we will see you back soon. Thanks a
Okay,
lot.
ma'am. Sure, ma'am. We will again join January, ma'am.
Sure, we'll look forward to it. Thanks. Bye for now.
Thank you, ma'am.
Good evening,
Thanks, ma'am.
everybody.
Thanks, ma'am. Thank you so much, ma'am. Thank you, ma'am.
Thank you, ma'am.
Ma'am, actually, you are speaking like Google.
Okay, I will just assume that that's a compliment. Leave it at that. Okay. Yeah. Thanks. Thanks once again, everybody. See you soon. Yeah, to everybody who has been following along and you have been with us for a while and you know what's going on, welcome back. I guess I think we can go back to where we sort of started from. I think in the midst of just handling logistics, I'm not even sure if I properly introduced Surya Prakash to you. So it's taking over instead of Arjun for today, as I hopefully mentioned earlier. And what we will be doing is we will be looking at a couple of the past programming assignments. And thanks for your time here and for staying through this, and to many of you for helping out in the chat, because I think I was a bit overwhelmed with the questions. So thank you on all counts. And for now, back to regular programming, no pun intended. Surya Prakash, if you can take it back from here. And yeah, thanks. Thanks once again.
Yeah, no issues. There are some people waiting in the waiting room. Can you see that?
Okay, I'll handle that. They might end
Yeah,
up being pronto, but that's okay. I'll take care of it. Thanks.
I'll just go through the statement once if anyone has missed. So we are given a rooted tree, which has n nodes, and each node is numbered from 1 to n. So, and each node has a weight, which is represented by wi. So ith node has weight wi, and our goal is to find a pair of nodes u comma v, such that u is an ancestor of v and wu minus wv is maximized. Okay. And the constraints are 1 less than or equal to n less than or equal to 10 power 4. So we should be able to come up with something of order n algorithm to solve this thing, right? Okay. So let's say we have a tree. Let's take an example. Node 1, 2, 3, 4, 5, and 6. Okay. So we, for example, take this node 3. 3 is an ancestor of 4. So the difference of weights will be W3 minus W4, right? So for all such pairs u comma v such that u is an ancestor of v, we compute wu minus wv and then take the maximum over all such pairs. Okay. Now suppose we fix the node u. Let's say this is node u. Okay. Let's say this is node u. If we fix node u, then to maximize this wu minus wv, we need, since the node this is fixed, we only need to worry about this expression, right? So this minus wv, we need to maximize minus wv, which is same as minimizing the value of wv, right? So for all the descendants in the subtree of all the descendants of u, we can find the let's define xu to be minimum weight of minimum weight of v, where v is a descendant of u. Okay.
All right.
So,
hey, sorry to interrupt you.
Yeah.
I was just wondering if, so my understanding is, actually I have a poor memory, but I've been told by a couple of people in the chat that I think Arjun went over this last time. So would it be possible
okay.
to pick up the problem from, say, week 6, I guess?
Okay.
6 or
He told me that he was going to do. He told me to do week 5 and week 6. So
Okay, so maybe let's do
yeah,
week
yeah.
6. I think that's in the intersection of what people want and what you may have looked at. Yeah.
Week 6, right?
Yeah. Let's.
Okay.
Anyone in the chat okay with that? Give me a +1 quickly. Yeah, so Ayush, I think we may anyway not have time to get to the week 7 problem because of where we are right now in terms of time. But let's maybe, I think week 6 is a good compromise. Raj, so if you're interested in the week 5 problem, you could look at the recorded live stream from last time. Actually, last time, where we went over that already. Yeah. So for those of you who are following along, quick +1 if you're on board with week 6. Yeah. Okay, good. Perfect. Thank you. Let's go with week 6.
Okay. So programming assignment 1. Okay. So Alice, Bob, and Charlie live in a country where there are n cities. The cities are numbered from 0 to n-1. For every ordered pair of cities UV, there is a flight from city U to city V, which costs CUV rupees. Alice is initially in city A, Bob is in city B, Charlie is in city C. So Alice wants to visit Charlie, but is wondering if she could visit Bob before that. Okay, so there are two ways that to travel. First option is Alice directly visits Charlie without visiting Bob. So that she would be traveling from city A to city C directly. As in, like, she might be taking some flights in the middle, but she will be traveling from A to C. And in the option two, first she will visit Bob in city B, and then she will visit Charlie from there. Okay. So the path will be, first she will be traveling to B through some flights, and then from B she will travel to C. So we need to find the minimum total cost if she goes with option two. Okay. And if she goes with option one, how much money will she save? Okay. The constraints are, there are less than or equal to 200 cities. And yeah, these are okay. So since the okay, since the n is very much less, like 200, we can okay. So we have a graph, and there are some flights between each city. So we can use is Floyd-Warshall covered? Yeah. So we can use Floyd-Warshall algorithm to compute the minimum distance between each pair of cities. So like, and since the weights are positive, like non-negative, we can use that algorithm. We wouldn't have any issues with using that. So we can use Floyd-Warshall's algorithm to compute minimum distance from U to V for each pair U comma V. And since Floyd-Warshall algorithm takes O of n cube time runtime, and we have n is very less, so we don't. It's fine. It will work. So once we know the minimum distance between every pair of cities, now to compute the minimum distance, consider this option two. Okay. So Alice goes from city A to city B, and then from city B to city C, right? So the two paths are independent. Like, it doesn't matter which path we take from A to B. It doesn't affect the path we take from B to C, right? So we can optimize, minimize both those costs independently. Like, we minimize the cost from A to B, and then minimize the cost from B to C, and then add them up. And from Floyd-Warshall's algorithm, we have already computed the minimum distance between from any pair, between any pair of cities, right? So we know the minimum distance from A to B and minimum distance from B to C. So adding them up, we get the minimum distance from A to C through B. So we know we can find the value minimum distance using option two route. And coming back to option one, so in this option, we don't worry about Bob. So we just visit Charlie, and we don't care whether we are visiting Bob or not. So this is basically just the shortest, the minimum. Yeah. So this is, in this case, it is just minimum cost from A to C, city A to city C, and that is also computed already from Floyd-Warshall. Okay. So yeah, that's the idea for this problem. We basically have to use Floyd-Warshall, and then this will be, let's say, if D U comma V represents the minimum distance from U to minimum cost from U to V, then the answer for this will be D of A comma B plus D of B comma C, and the option answer for first option will be D of A comma C. Okay. Did everyone understand that? Is there any doubt? Hello.
Oh, sorry, I think I was on mute. So yeah, I think there's some messages in the chat saying
Yeah.
it's all good. So
Okay. Cool.
right. Cool. So
Yeah. If there is any doubt, please type it in the chat, or I will move on to the second problem.
yeah, I don't see any specific questions.
Okay.
I haven't been doing it, but I will monitor the YouTube stream as well, just in case something
Okay.
comes up there. I'll just interrupt you. Yeah. But
Okay,
I think for now we could just move on to the second problem on basics. Nice.
I have done it using the extra algorithm, like considering every node as source.
Yeah,
node
we
and
can use Dijkstra's algorithm as well.
Yeah.
I think in that case it will take n square log n time, because there are n square edges. Like, there is an edge from between
like
every pair.
first first implementation of Dijkstra's algorithm, where you have implemented it within the time constraint of quarter of
that will take O
n
of n
square
square.
plus
Yeah,
m. Yeah.
yeah, that will also work. That will give O of n square runtime. Yeah, that will be faster than this. Yeah, nice idea. Okay, moving on to second one. So you are given a string s1, s2, so on sn of length n. Each character of this string is a digit, 0 to 9. You have to start from s1 and have to reach sn. To do so, you can make multiple teleports. For a particular si, you can teleport to si minus 1 or si plus 1. So like you can go forward or back. And you can also teleport to some sj such that si equal to sj. So if the digits are equal, then you can also teleport directly to that digit. Find the minimum number of teleports needed to do so. Okay. And n is of the order 10 power 5. Okay. Yeah. So there can be other ways as well, but I will use graphs to solve this problem. Okay. So we can create a graph of n nodes, like each corresponds to, so ith node corresponds to si. So this is 1, 2, 3, 4, and 5. Oh, sorry, n. Okay. So we and add edges between between every two consecutive nodes. Okay. And now we create 10 more new nodes. Let's call them D0, D1, so on, D9. Okay. So each of these new nodes corresponds to a digit. Okay. So the one way to see this problem, like let's forget about the constraint 10 power 5 for a second. And suppose I add an edge between from I to j for every I comma j, such that I add an edge I to j if both of these digits are equal. Okay. So if I add such edges, then the answer, this minimum number of teleports, would be just the minimum distance from 1 to n in that case, right? Because what are these edges representing? So this edge basically means that I can move from 1 to 2, right? Here it is said that I can teleport from si to si minus 1 or si plus 1. So each of these edges represents the possible teleportation. Like you can use that, you can teleport from I to I minus 1 and I to I plus 1. So we add an edge between those two. And also we can teleport from I to j if both of those digits are equal, right? So that's why we add an edge from between I and j for every pair I comma j such that si equal to sj. So there is an edge if both the digits of I and j are equal, that is si equal to sj, then I add an edge, right? So it means that I can travel through that edge. I mean teleport from I to j. So once I create this graph, so after that I just need to find the minimum distance from 1 to n, for which I can use BFS, since by taking weight of each one, we just need to do BFS. No need to do Dijkstra in that case. Okay. But the issue with this is there can be, if the digits of all the nodes are equal, or like half of the digits are equal and the other half are some other digits, then there can be n square edges in the worst case. Like there can be an edge between every pair of vertices in the worst case. So that would blow up the algorithm to O of n square plus n runtime. So to overcome that, what we can do is we create 10 new nodes, D0 to D9. Each of these nodes represent, so D0 represents digit 0, D1 represents digit 1, so on till D9. Okay. Now forget about this thing, like only we initially created only this path, like connect 1 to 2 and 2 to 3, 3 to 4 and so on. Now let's say for every si such that si is a digit 0, add an edge from d0 to that I. Okay. So let's say and for d1 add an edge from d1 to every si such that si equal to 1. every I such that si equal to 1, so on. So for example, let's say 1 has a value of s1 equal to 2, s2 equal to 0, s3 equal to 9, s4 equal to 7, and sn equal to 6. So I connect an edge from D1 to D2, okay, since the digit is equal to 2. And from 2, since the digit value is equal to 0, I add an edge to D0. And from 3, since its digit is 4, add an edge to D4, and so on, okay. So once I connect this edges, for simply, okay, yeah, so give a weight of give a weight of 1 to all these edges, all the edges in which are connecting I and I plus 1, and give a weight of 0.5. Let's change that later. For now, just consider we are giving a value weight of 0.5, okay. So now if I perform Dijkstra or whatever, if I see the shortest path from 1 to n in this new graph, shortest length of the shortest path in this new graph, it will be something like it will start at 1. We may go to 2, 3, and so on, and somewhere in the middle we will travel to some di from k, let's say, and then go back to some l, and then do some and then travel forward using these edges, and then go to dj some and so on. Eventually we will end up at n, right? So see these type of edges. Here the weight is 0.5, and here also the weight is 0.5. So we are so from k to l, the total weight will be 1. So now in the previous graph where we connected I and j as si equal to sj, so this will be the same thing. This is just that will be the same as this thing, right? Like from k to l, effectively this is an edge of length 1, right? And we have an edge from k to di and l to di. This means that k and l both have digit equal to I. So in the previous graph there was an edge from k to l of length 1. So the shortest path in this is same as the shortest path we get in the previous graph, right? Is it clear till this point? Is anyone having an issue? I will continue.
No, yeah, till this point it's clear.
Yeah. So we just need to build this graph with n nodes and these 10 new nodes which represent digits, and these represent the indices in the string. And in this n nodes, connect the adjacent ones. I mean 1 to 2 and 2 to 3, 3 to 4, and so on. And between these 10 nodes and these n nodes, so we connect an node I to node dj. If digit representing si, I mean digit representing I, which is si, is equal to j, okay? And then we give a weight of 1 to this and a weight of 0.5 to this, okay? And then find the shortest path from 1 to n. Now 0.5 can be hard to deal with, so we can instead give a weight of 2 to all these edges, and give a weight of 1 to all the edges between I to dj, these type of edges, like these edges. So now if we find the shortest path, we get that after finding the shortest path, we have to divide it by 2 because we have multiplied the weights of all edges by 2. So so now we just need to apply the Dijkstra algorithm, and it will work because how many number of nodes are there in this new graph? There are n plus 10, right? N plus 10 nodes, and the number of edges. So there are n minus 1 edges these type of edges, there are n-1 adjacent ones. Sorry. Plus, and between these D0 and DJ, there are no edges between these among these. But and for each node I, there is exactly one edge connecting it to some DJ, right? Which is just if, for example, here the value is 2, so I am connecting it to D2, and I'm not connecting it to any other node. So there are n edges of these type, right? For each node, there is exactly one edge connecting from this to this. So there are total of 2n-1 edges and n plus 10 vertices. So there are O of n vertices and big O of n edges. So the Dijkstra, if we apply the Dijkstra algorithm now, it will take n plus n log n, which is fine because n is of order 10 power 5. So is this clear to everyone? If you have any doubt, please type it in the chat so that I can see. Okay, I don't think anyone has any doubt. I'm assuming.
We need to output the half of the total.
Yeah, since we have multiplied the edge weights with 2. Yeah.
How did you get the intuition of creating the dummy vertex and connecting it with the same digit?
Okay.
It's very
So yeah. So okay. Whenever I try to solve problems like this, I first try to forget about the constraints and like think how I can solve it like in worst possible way, like the brute force way, and then slowly get the intuition of how I can optimize it further. So for example, we have created this graph before, right? First, we have added the edges directly. So that's a possible way, like anyone can think. Like we just add edges where there is a teleportation possible from I to J, every possible edge, and then do the Dijkstra, right? So, but the issue was there were n square edges. So yeah, so I try to come up see if we can overcome that. And since the edges, those n square edges that we are getting, those are mostly the edges are between same equal digits, right? So I created a dummy node where I can travel through that node, right? Yeah.
what I have done, like my 21 test cases are passed and 7 of them get for failed. Whenever I encounter any new digit, I just connect it with every digit which have the same value, and because it can make the graph disconnected, so I connect them with the adjacent node also. Okay, like number of edges we won't go up to order of n square because I'm always connecting the first digit with every other digit which have the same value.
Yeah.
And assign it the edge weight of 1, and connecting any node which is adjacent to it, and assign the edge weight of 2 to it.
Okay.
And after that, when I apply the Dijkstra's on this task of 21 out of the 28 test cases are passed and 7 of them get failed. Like, I don't know where. Like building the graph is most important thing in this question.
Yeah.
I think I have made some mistake. I didn't realize it though. So where did I make mistakes?
Okay. So
is there any way to do it without using that additional graph that we use?
Sorry.
Sorry, can you repeat that?
Can we do it in any way without using that other graph that we used?
You mean these extra 10 nodes?
Yes.
Let me think.
what I have
I
done,
don't
like
think
I
so.
didn't create any dummy vertex. I just connect the every indices, uh, not every indices, like the digit which have the same value. I connect.
Yeah. Yeah, I don't think we can do it without adding these dummy vertices.
Yeah,
Yeah.
I can now clearly see like this is the good intuition.
Okay. Can you discuss some edge cases using? I didn't get what exactly you're saying. You should get using a mapping.
I guess I would by default interpret that to mean that I don't know, special situations, like is it different if n is equal to 1? I guess no. Is there anything that we have to watch out for? I'm also thinking about that.
I don't think there are any. I mean, if we follow this approach, there are no corner cases that we need to deal with. It depends on what their approach was. Like,
Oh yeah, so in the context of a different, different implementation or a different approach to the problem, then Ayush, I think you may have to. So Ayush, did you try something that was similar to this, or are you asking for edge cases in the context of the explanation that that was just given? Because in this context, I think probably there isn't too much more to do.
yeah.
Just try to implement it straight up and see what happens. I think it should work. But yeah, maybe Ayush, relative to your implementation, maybe there were some corner cases that would have needed attention. So for that, we'll have to kind of discuss what your implementation was specifically. Yeah. So we are always happy to look at specifics. If it's not me or Arjun directly, somebody from the TA team, or in fact, you guys have been amazing at looking at each other's code as well. So in general, to anyone who's listening to this, please feel free to post, especially after the assignment deadlines. You can certainly share your code snippets or your approaches and run them by others, especially if, like, I think someone was saying you missed out on like the last 20%, like maybe the last subtask did not go through. So you probably had an approach that was almost correct, but just slightly suboptimal or something like that. So we could certainly discuss each other's approaches. I think those are very healthy and like fun discussions to have in Discord. So please feel free to do that. And you're also welcome to open up like older problems and talk about them. That's fine too. And just a reminder that we tend to post a lot of extras on the course website. We keep adding to these lists. So, if at any point you're bored, like you might have been for the last few days, because we haven't really released week 8 material when it should have been released, please feel free to check out the extras, the suggestions for other practice problems that you can try out on standard contest platforms. And hopefully that's a fun way to stay occupied and keep practicing. In the meantime, I think I owe all of you an update on the course timeline and content. So we should definitely be seeing week 8 and week 9 material released tomorrow. This is based on flows, and you'll see a lot of like basically trying to come up with wacky ways of building things. It's essentially a graph algorithm, but it applies very widely and beyond the context of graphs often. So hopefully you'll see a few examples that kind of illustrate that. So we're releasing week 8 and 9 together. You will see a couple of algorithms for flows. Maybe not like maybe not all that is there to be seen, but I think you'll see enough to get you pretty far along. And what you will see is a lot of examples of how these algorithms are applied. And with this, actually, we will be wrapping up on like the theme of graphs overall. This will be our last pit stop as far as graph algorithms are concerned. And after this, we will move on to dynamic programming, which is, I think, one of the most sort of ubiquitous techniques that's there. And you've already seen a bit of a DP flavor and, things like, let's say, Bellman Ford, Floyd Marshall, and things like that. So it shouldn't be completely a new thing, but I think we will go through it in a fairly systematic way. So I expect that material for the last 3 weeks will also come through by early next week. So you can tackle all of it together. And yeah, I realize we've been slightly behind schedule relative to the normal NPTEL calendar, but I think the way we release the remaining materials will hopefully compensate for it. Yeah. So yeah, Udit, I haven't been trying, so, but apparently, if you say so. Okay, so with that, I think we are a little over the hour at the moment. So let me know if you have any pressing questions that you would like us to address. We probably, will be taking up week 7 plus hints for week 8 and 9. Plus maybe approaches to the contest that we did around 17th September, maybe after we announced the winners and so on. We'll probably take a look at, anything that you folks may have wanted to discuss from that contest. I think all of that can happen the next time that we meet live. Yeah. Okay. So, all right. Yeah, that's a great reminder. I think Code Forces is, is that Code Forces Day 3 tomorrow, Hardik? Oh, thanks.
Yeah,
Udit.
I guess.
Yeah, it's Code Forces Day 3. It's an excellent reminder. Yeah, I hope we see some relevant, problems. And it'll be good if, by the way, we can always do, I think there are at least 2 voice channels on Discord. So if anybody just wants to start a meetup like after the contest and, just discuss your approaches or whatever, feel free to do that. I'd typically be around. I'm happy to drop in if anyone's starting something. So that's something you could always do. I think we've done it once or twice and it was fun. So, so feel free to initiate something like that. Yeah. All right. So, by the way, I don't know, Ayush, if you are raising your hand right now, or if you had raised it earlier for something else. If you have something to say, then please feel free to unmute yourself.
Is there any other contest that you will?
For this course, I certainly hope so. Arjun has said that he will try to speak with the coordinators of upcoming starters contests to see if we can make sure that, so I think one of the things about the contest that we just did was that it was not a rated contest. And it was a closed contest. It was just for the learners of this course. So we would like to be able to push some incentives for you all who are in the course to be doing well in a regular CodeChef rated contest, one that is open. The only thing was that I wasn't sure if the syllabus for a typical starter contest, how well it overlaps with what we have done. So I think we definitely haven't touched upon a few pretty fundamental topics. So so we're going to try and see if one of these starters can be made to be slightly aligned with what we have done in the course. And if so, then we will just use that as a contest that we can say, oh, among the people from this course who do well in the contest, you get a t-shirt or maybe a book or something. But if not, then we will just do another unrated closed contest. But however we do it, we'll definitely have one more contest after, most probably after the NPTEL exam, because I think right after the course, the NPTEL written exam will probably be a priority for those of you who are doing this officially. So we'll probably do the contest sometime in November. That's the plan. But frankly, I have no idea. I think it should help in general to make you a better problem solver and hopefully give you more excuses to practice coding, which I think can never be a bad thing. But yeah, I mean, I don't know specifically if it helps you with a goal that's not, specialized. Yeah. But good luck though, if that's on your radar. Certainly all the best. Yeah. Cool. All right. Any other questions? Otherwise, we could call this a wrap. I think we're, as always, a little over the hour, but this time for slightly unusual reasons. So for everyone who has been following along, and yeah, we had a bit of a detour, but I guess it was a fun one. So we'll, catch up at the usual time. For now, the next live session will be by default at Saturday, because I don't think, I'm now not really sure if we should have been doing this on Mondays and if that's better, or some other working day. But for now, we'll just default to doing it on Saturday at 7 p.m. To talk about some of the things that I just mentioned that we didn't have time for today. Okay, so yeah, Hardik, I really appreciate that. Thank you. In fact, I think one of the reasons that, I don't want to be making up too many excuses, but I think one of the reasons weeks 8 and 9 took a while is because we rolled back some of what we had planned originally based on the kind of feedback that we're getting. So hopefully this will be a nicer experience overall, even if it's slightly delayed. So I hope so. Udit, for the Saturday live class, if you join the Discord community, you'll automatically get the link. I think that may be the easiest way to make sure that you keep track and join in. Yeah, because I'm not sure how to engineer the mix-up that happened today, so so I may not be able to promise you that. But just join Discord if you're individually interested in hopping on. Yeah, cool.
Ma'am, can you suggest me some topic that I can study to, understand the Saturday class?
Sure. So on Saturday, we will very likely be discussing the material from week 7, which was minimum spanning trees, I believe. If I remember that right. Yeah, I think so. If you look up, let's say, Prim's and Kruskal's algorithms for minimum spanning trees, that would be great. So on the course website, you could just head over to the week 7 material, and there's like 3 or 4 videos there. If you have the time, you can check those out. Or I think there's some references to textbooks as well, sections in textbooks. So if you prefer to read, you could just read. And that should help you prepare.
Okay, thank you, ma'am.
All right, cool. It was great having you all, especially to the newcomers who are here by accident. Thanks for staying back so far. Appreciate your being here, and to everyone who has been with us all along. Thanks as always. So we will continue the conversation on Discord, and until next time, which is Saturday 7 p.m. Thank you, and see you around. Have a great evening and a good week ahead. And let me know how it goes with weeks 8 and 9 once you have the material. I, as always, look forward to your feedback. All right, cheers, bye-bye, good night. Yeah, I'm glad you enjoyed it. So did we. It was lovely having everyone, and a special thanks to Surya Prakash for stopping by on short notice and giving us some excellent intuition. So thanks very much.
Yeah, you're welcome.
Cool. On that note, good night and bye-bye, everybody.
Bye.
Thank you, ma'am.
Thank you, ma'am.
Yeah.
Bye, and thank you, ma'am.
Thanks.